Welcome.
To the joy of coding.
Hello, and welcome to episode 87 of The Joy of Coding. My name is Mike Conley. We're going to be doing some more hacking on Rust stuff today for Mozilla. It's going to be a good time. I am live broadcasting, hopefully, across Air Mozilla, Twitch, and YouTube. I don't appear to be dropping too many frames. Hopefully, the quality is a little bit better this week. I know last week it was a little bit rough. Do let me know if you... if you have any feedback about the stream, I'll do my best to try and fix things. I do right away notice that there are like these black bars above and below me. I'm just going to try and fix that right now, live. 1 second. Whoop. Whoop. Hey! Hopefully that worked. Hopefully I haven't disappeared on you and you can see no black bars and I'm a little more zoomed in. Yay! So let's hope that worked, and let's see if it works whenever I share my screen. Yes, it appears to have. And yeah, these are some graphs I was looking at, but what I really want to show you is the agenda. And if you are on Twitch, I'm going to give you a link to that in the chat. Here you go. I'm also going to drop it in the live hacking channel if you happen to be in there. And if you're on Air Mozilla, there's a link to the agenda in the additional links section. So you can scroll down there, find the additional links section, and click on it. Or if you're on YouTube, it should be in the video description. So, what is this agenda? It's sort of a kind of a high-level plan of what I want to do today, but I'll also take a little bit of some notes. Things might not go according to plan, or a reminder that no plan survives breakfast, so, you know, everything might go horribly wrong. I might spend the entire time attempting to fix my stream, hopefully not, but it could happen. And, you know, we'll just do our best to get through this. So what are we doing today? Well, first, I want to make sure that everything is working. So yes, I'm streaming at 24 FPS. I'm not dropping any frames. You can hear me, and I'm recording. So all is well there. I should hopefully be live broadcasting across Twitch and YouTube as well as Air Mozilla. I don't want to check. I find that whenever I check, if I go to a site and like I'm streaming, and then on the machine I'm streaming on, I go to the site where I'm streaming. It gets very confusing, and then I start dropping frames like crazy, probably due to all the network stuff that's going on. So I'm not going to do that. But if you have any comments about the stream, do let me know. Drop them into the chat, or send me a message somehow. Okay, so let's get down to business. What do I want to do today? Well, I want to write more Rust. Last week and the week before, we were working on something called the IPDL parser, which is part of sort of the build process, the build mechanism for Firefox, where we have these things called IPDL files. They define a inter-process communications language / protocol. So you create this IPDL file, and then the compiler, the IPDL compiler, spits out C++ headers and definitions that can then be imported, and you like write code that subclasses the sort of boilerplate that the IPDL parser generated for you. So yeah, the IPDL parser takes care of a lot of the boilerplate, and it also makes sure that it's clear what the communications protocol is, like it's in one place, despite the fact that it needs to like be mirrored exactly on one side or the other. The way we get around doing that is having the machine create those mirrors, if that makes any sense. And by other side, I mean like on each side of the process barrier, because what we're talking about here are two different programs that are talking to each other over a pipe, and so you have to make sure that they are communicating with the same plan in mind, that they have the same notion of how communications are taking place, and that's what the IPDL file is for. It defines the language for communicating across the process boundary. And so what we did last week was we wrote some tests. Let me, what do I want to show you here? I'm going to bump up the font. Boop, 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 boop. What we did was let me change into the directory of the parser. If you're interested in this code, I should send you to the let let me get rid of some of this other stuff, and I'm going to send you to this GitHub page. Whoa. What happened to my awesome bar? Awesome bar is currently, there it is. A little bug there. IPDL parser. Oh, this is my GitHub clone. This is the repository that we're talking about here. Andrew McCrate's IPDL parser. I'm going to put that in the agenda in case you don't already have it. And this will synchronize, and if you're already looking at the agenda, you can reload it, and it should have this link in here now. So this is the repository we're dealing with. There are a bunch of commits in here already. There's a bunch of code in here already. I've written some of it. This is what we wrote last week. It got merged in. I'm very happy about it. What we did basically was wrote some tests, so there shouldn't be anything to pull in. If I pull McCrate master, there shouldn't be anything new here. Yeah, we're already up to date. So if I do cargo test, we should be able to run the tests that we wrote last week, and everything should pass. And I'm just going to bring up the bottom of the terminal so you can see it. And so, oh, wow. We failed a test. That's interesting. That's not expected. Unexpected token in empty.cpp. Unexpected token empty.cpp. Stat. Oh, you know what it is? There's actually I've been messing around, and I think I accidentally created a file in here that I didn't mean to. CPP? Or no, yeah, empty child. That's where it is. Yeah. So, okay, I'm gonna move empty.cpp, and there's probably a header. Yeah. Let me list everything that's empty. I've got empty.cpp, empty.h, and then everything except empty.ipdl and empty_struct.ipdl. I want to move that elsewhere. I'm just going to create like a little workspace just for now. Don't worry about it. I'm going to move empty.cpp and empty.h. I think I can move multiple files at the same time, right? Works. That worked, right? I don't know if I've ever done that before. Yeah, that did work. Okay, move empty child dot star and empty parent dot star also to workspace, and then there should only be the two IPDL files. Great. Okay, so now if we run our tests, this should pass correctly. What? Unexpected IPC message start .h. Excuse me. I don't think there's supposed to be a .h file in there. I think I may have accidentally created one. IPC message start.h. Like, is there anything else in here that's not supposed to be in here? Ah, you know what? That's what we should be removing. IPC message type name, IPDL lex, IPDL yak. I don't know why we have these lex and yak things in here. So now if we run, we pass. Okay, so there was a bunch of garbage stuff in the directory, and I think I'd accidentally created that a little while ago. And that's what's up. So we have our passing tests. I've for some reason modified compiler. Let's see what changes I made. Oh yeah, I started to like I stubbed out a new function, and that's kind of what we're working on today. Because what I want to do is I'm going to install these updates tonight. Try tonight. What I want to do is now that we're parsing some IPDL and we've got our AST, we're going. So this is a syntax tree thing. We're going to take that AST and we're going to convert it into C++, the boilerplate. We're going to try and do just a little bit of it. Now, what I want to make sure that we do is not redo the mistakes of the past, because the IPDL parser, one already exists in Firefox today, or in the Firefox build system. It's written in Python, and the reason that we're re-implementing it in Rust is, well, one, Rust is awesome, but also because the original Python IPDL parser is really, really hard to reason about. I think it's my understanding, having read through it a bit now, is that it's a very complicated, and quite over-engineered for what we need to be able to do with IPDL parser. And that means that it's kind of hard to work with. It's hard to evolve the IPDL language, the protocol language, and we want to make that easier. And so there's an issue that I opened up. I've linked to it in the agenda. This is issue number 16, where I ask before diving in, and I find that this is always a good policy if I'm contributing to a project. You know, these are my colleagues: Nathan Freud, Bill McCloskey, Andrew McCrate, who owns the repo. These are my colleagues, and I believe they trust me. But at the, you know, just because they trust me doesn't mean that I'm always going to do the right thing. I can make mistakes all over the place, and so I'm getting their input on how they think I should approach this problem, especially because I never hacked on the old IPDL parser. I never worked on the old Python-based one, and I never ran into the difficulties of working with it. So if I'm not careful, I might accidentally recreate the same conditions of the old IPDL parser, and then you know, now we've got the same old problems, except it's written in Rust instead of Python. So I'm asking for feedback on how we should write this thing, and I got some. That's basically this entire block is how should I do this? Here's my idea on how to do it, because I find that that's always a good way to ask questions. Actually, there's a great comic about this, Bork asking questions. There's a great The Art of Asking Questions is a great little comic. I'm going to put this comic link in here. The Art of Asking Questions. Because there's this like section where doing some research or state what you know. These are both things I'm trying to do where like I'm not just asking how do I do this. I'm saying here's what I'm thinking of trying to do. These are the approaches I'm considering using. What do you think? Which is better, I think, than saying, how do I do this? So that was me doing that. And then Nathan Freud, he's written a bunch of stuff, but I'm going to boil this down for you. Basically, he's saying that we have, like this, the IPDL parser isn't the only place where we generate C++ from some other format. There's another thing that we have called WebIDL. This is something that I believe is a standard across a standard. This is a what is it? Web Interface Definition Language is what it stands for, and it's used in multiple browsers. This is how we like make sure that we share the same APIs, web APIs, so that like not some browser will get like the arguments wrong and some DOM API. So we have these web IDL files that, you know, browser vendors can share with one another, and then we take those web IDL files and we parse them, we turn them into the stuff that we can then like stub out and implement. And so this code that we use to parse WebIDL does a similar thing to the IPDL parser. And Nathan Freud said that the approach that the WebIDL parser uses is actually pretty good, and it's nice and simple. And he says you should look at that. And Bill McCloskey says he agrees with Nathan. Now, Bill McCloskey is the one who, I think it was his idea, or he's a big proponent in moving away from the Python-based parser. And he was the one, I think, who was running into a lot of difficulty dealing with the old Python code. So I'm weighing his impressions and his feedback about the original Python parser very heavily, because he's more or less the client I'm attempting to satisfy here if we're going to use that model. He's the person I'm trying to make sure that like we've made an improvement. If we end up with a Rust-based IPL parser and Bill doesn't want to hack on it, if Bill thinks it's just as bad as the Python based version, then we've failed. So I'm weighing his feedback very heavily here. He says, yes, the CodeGen, that's the WebIDL parser approach, seems much better. He has additional comments. Please try to avoid visitors. And he's referring to my comment up here where I was going to use the visitor design pattern to walk the AST from the parser. He's saying we should avoid that. When you can, just match on the syntax tree. Visitors can be useful if the syntax tree is deeply nested, but you only want to process one or two kinds of nodes, but the IPDL syntax tree is pretty shallow, and so I doubt they'll be needed much. So that's already a grand simplification, because the original Lower.py is where we have the original IPDL parser, and it very much uses the visitor pattern. It's got like type visitor. Yeah, it does all of this like design patterny stuff where it visits certain nodes and does certain things. And Bill's like, that's overcomplicated for what we're trying to do, because a design pattern is not a magic bullet. It's just a thing that it's a pattern you can consider. And though some of the times a design pattern will be like useful for some problems, for this particular problem, it appears to not be a perfect fit. So let's not use a visitor. I'm going to write that directive down in my notes. So directives on this bug. 1. Don't use the visitor design pattern. Match on the syntax tree manually, and yeah, that's it basically. 2. He says we have a lot of problems in IPDL where something is used without being defined. This can take the form of not using the if pragma preprocessor define include directive within a header, or not pre-declaring a class, or forward declaring a class. Cases like this are where it will be useful for the code generator to know more than just text. Maybe if you use a name that will be defined globally, you should be required to do something special so that the code generator knows about it. That way it can decide what the proper includes and stuff are. That almost to me sounds like an extension of the IPDL syntax. So like we would need to modify the parser to or the language itself to say like I'm using a global name. So I'm gonna put that as a non-directive, but as like follow-up work or issues to file. I'm also gonna bump up the font here. And then I'll use checkbox here. So add file. Consider what do I want to say? Consider adding a mechanism within the IPDL language where we can declare that we're using some kind of global name so that the parser can figure out what things need to be included or forward declared. Okay, so that's these two. IPDL has the unfortunate property that it generates everything at once. It would be nice if we could generate one CPP.H combination for a given IPDL input at a time. That's true. So we generate usually 4 things at the very least. We'll generate the parent, because there's a parent-child relationship. You have these 2 ends of the IPC channel. And we call one of them is considered the parent, one of them is considered the child in the relationship. And we create a header and a definition file for each one, so that's 4 in total. And Bill says it'd be nice if we could generate one combination for a given IPDL input at a time. Besides Sandy, it's nice to do it that way so that when you change one IPDL file, you don't have to recompile everything that depends on any IPDL file, which is basically everything. Okay. Generate one combination. So add ability compiler should know if we're generating the parent or child parent, child, or both boilerplate. Okay, I think that's what he means. And then the last, if you can, try to split things up into multiple files. If we could have separate modules for generation or send receive code versus type serialization, That would be nice. I almost never look at the type serialization code, but the message code gets updated a lot. Try to separate type serialization code from what was it? Send receive message code. Okay. Okay. We can try and do that. Now what I want to do is do the bare minimum. I want to like put a thing together that's the bare minimum that at least does not violate any of these directives. If it doesn't satisfy the directives, at least doesn't violate them, if that makes any sense, or doesn't actively shoot myself in the foot for later on. So what I mean is, and I think this is kind of goes back to what I was doing before with those empty things. So we have the we have these tests that I was talking about, and inside of one of these, there's one of these is called empty.ipdl, and it's just an empty protocol with a single async message that comes up from the child that is just called message, and it doesn't do anything. And I ran the old parser on it, and what it spat out was what I put into Workspace here. It actually spat out other things. Let me see if... Here's what I'm going to do. I'm going to actually remove empty. I'm going to remove everything here. I'm going to run the IPDL parser again, the Python-based one. But I'm going to have the output go into this directory. So how am I going to do that? Well, it's kind of tricky. I have to actually enter the virtual environment. Virtual env. I think I have to do that. I have to enter the virtual environment for a Firefox build before I can do that. And then I'm going to do workspace. I'm going to say Mozilla Central IPC IPDL IPDL.py. Let's see if I can call it Python. So I have to pass it some options and some IPDL files. Now, what are the options I can pass to it? I don't remember. Oh, I'm in the wrong project. Whoop. IPDL.py. Include verbose quiet out headers out C++. By default, it'll be the current directory. Okay. So we should be able to do IPDL, and then I'm going to say tests okay empty.ipdl. Okay, and now here's all of the stuff it made. Now some of this isn't just like it created a bunch of stuff. It created something called IPC message start, which is what? Message start.h. Empty message start child. And then there's something called IPC message type name. So this is all like, oh, this is a type of message, right? This is the okay, return empty message. I have a feeling if we this does need to be generated. String from IPC message type. So that's important. So I guess we're going to have to create that as well. And then we have empty.cpp, which is all of this sort of funky stuff. All this sort of boilerplate. And then empty.h, which is the header, and so it creates a namespace for it. Okay, and then we have empty child, which has a lot of boilerplate in it, like holy smokes, a lot of boilerplate. And this is doing the work of like receiving a message and then dispatching it properly. Then we have empty child.h, which if you're going to use the empty protocol, then you have to implement some of these, like you have to implement receive message, actor destroy, processing error. Um, yeah, some of these that I guess only top level protocols get. Entered CXX stack, entered call, and then for empty parent, I think it's the same thing. Did empty parent, state, send message. Yeah, a lot of the same thing. And then we have these IPDL Lex tab. What is this? This file automatically created by PLY. Tab version 3.3 Lex tokens. What is this stuff? Why are we creating this Lex and Yak stuff? Yak tab. LAR. So wait, why did we create this? I'm very curious about that. I'm gonna quickly DXR for this, see if I can find some reasoning there. Garbage. What? The IPL compiler manages IPL to age CPP dependencies itself, which is why we don't have explicit targets. Python, top source directory, line include IPDL dirs. And then I think it just throws this stuff out. Garbage. I think it just throws it out when it's done. I don't think it's ever used. That's ridiculous. Or IPDL Yak tab. Yak tab. Is maybe that's generated by, oh, here we go. Parser. Tab module. Whenever we parse, we're using Yex, your Yak, yeah. Maybe it's because we're using Lex and Yak to do the parsing, and that's just sort of like what it outputs. Maybe that's how Lex and Yak work whenever we use PLY, Python PLY, Python Lex Yak. Is there like documentation? What was it? Tab module? No, I was somewhere else. Where was it? Tab module. What does tab module mean? If you want to go somewhere else, you can give an absolute package name for tab module. In that case, the tables will be written there. The tables will be written there. So this is an artifact from using Lex and Yak from PLY, which is the Lex and Yak bindings for Python, I guess. Huh. So that just gets thrown out. So we can ignore those. We can ignore IPDL because we're not using Lex and Yak. We're using something called Lallerpop for Rust. So we've reduced some of the complexity. So what we end up needing to create is either like maybe we need to output IPC message start and IPC message type name. I'm very interested in actually seeing what that looks like whenever, like in the real world, whenever we've used the Python-based one, because I want to know if it's like all of them. Like IPC message type name currently for our example there has like a single, I think it's like a mapping between, let's see, IPC message type name. It's this mapping from some kind of enum to a string. And I wonder if we just end up connecting all message types across like all different IPDL files in this common, what is it, IPC message type name thing. So let's take a look. We can actually DXR this because we have generated files in SearchFox, and or we should, IPC message type name. What? We didn't see it. So let's look inside obj. Find it. There it is. Sorry, you probably can't see. Let me bump that up. Bump it up. The jam. People talking in Twitch. Do you monitor the chat? Asks Master Dover. That was... he asked that like 25 minutes ago, maybe more. Dover. Only sometimes, and I won't, but if you say my Twitch nick in here, I think my IRC client will get my attention faster. So if you go mikeconley.ca, hello, I have a feeling I'll hear about it. Okay, so I want to look inside that file. What was it? Yeah, HG, no, find, there. It's an IPC IPDL, and then that. And so does it have, I think it's gonna, does it have every single type of message? It does. Holy smokes. All of these things. And all it's doing is it's mapping enums to strings. I believe that's all it does. Whoops. Whoops, whoopsie daisy. I used to know how to go, I know how to get to the bottom of a file in Vim. How do we get to the top? Vim, go to top of file. Go to the first line. I think I've looked this up before. GG. So it is. That's so unintuitive. Or look, all these different ways you could do it. GG, colon 1, 1G, 1GG. We are in a silly industry. Okay, so the generator needs to be able to output base class example empty.c empty.h child classes child class empty child.cpp empty child.h parent class empty parent.cpp empty parent.h and what else? It was IPC message type name, IPC message mapping, and then what's message start? IPC message start. Start child enum IPC message start. IPC message message stuff, I'm gonna say. And I think we only ever need to do that if we are, like if we take the, I'm gonna do an experiment. If we have these files in here, and if we message start has empty message start child, I'm gonna copy IPC message start.h to IPC message start.old.h. I'm gonna copy IPC message type name.cpp to IPC message type name.old.cpp, and then I'm gonna run that old the Python-based IPDL parser again. Do it again. Here it is. I'm going to get rid of the Python. Oh, did it? Why didn't it create the Python? Well, hang on. And then I'm going to delete message type name.cpp. I'm going to delete message start.h and then run that again. Okay. And then I'm going to compare. Well, of course, I haven't. Silly. There's another part of the experiment. IPC message start.h. I want to change the IPDL. So I can actually test. Okay, empty.ipdl. Vim. Vim empty.ipdl. I'm going to change this so that we add like uint32t test. I'm going to add an argument, and we're going to run the parser again. So that's changed the signature of the function. And so if we look inside empty.cpp, there should be something called like empty child.cpp, for example. There should be, I should actually look at the header. We should be taking a receive message should receive, yeah, a uint32t of test. And when we send that message, parent.h will need to send, yeah, we send a uint32t test. Okay. And so now I've got these IPC message start and IPC message type name that were created for that modification, and now I'm going to do a comparison. Message start.h to IPC message start old.h. There's no difference, and if I do IPC message type name.cpp and IPC message type name old, there's no difference. What does that tell me? That tells me that this stuff doesn't change unless new messages are added. So it'd be great. If you should know for generating the parent, child, or both. Compiler should it's kind of tricky. Like, here's what I'm thinking. There's a kind of an optimization that Bill M is asking for, where we can dump out only some of this stuff, depending on, I guess, arguments or options that are passed to the compiler executable. How will make know whether or not we want to like generate just this or just this or just this? Let me go back to Bill M's comment. I have to recompile. So yeah, if we add a new message, this IPC message stuff is probably like IPC message start, for example, is probably imported in all over the place. Yeah, in like every protocol. So if this changes, that means so as soon as you add like a message, like a new message, IPC message start, the header will change, and that means we have to recompile all of these things. So that's what he's worried about. And probably the same thing goes for IPC message type name.cpp. Well, that I guess we don't care. We're going to be linking, we compile it anyways, and then it's like compiled and then linked. So that's okay. It's the header that we care about. So like one thing we can do is add an option to IPDL parser for whether or not we want to generate um, message headers. Generate the generic message headers CPP. So how would that work? Let's say you do a full-blown recompile, like for a clobber. So then the build system should know that we're clobbering and that we're going to tell the IPL parser, yes, generate everything. Oh, maybe it's because if we're you never want to regenerate the message stuff if you're just parsing a single IPDL file. If you're just parsing a single IPDL file, perhaps it's the only one that changed. You don't want to create a create the message header thingies unless a new message has been added. In that case, and even in that case, you'll only ever ping you back in okay. In that case, you'll only ever, unless a new message, and even in that case, you'll only ever want that stuff if you're parsing all IPDL files. So yeah, I think what we want to do is how do we make this smarter? Probably we're going to end up like generate one C++ H combination for a given IPDL input at a time. You don't have to recompile everything that depends on any IPDL file. I guess though, like whenever you parse an IPDL file, there's a tree structure. Okay, hold on a second. There is a tree structure for IPDLs because there's the root one and then things that depend on that root or hang off that root. So whenever you parse one of the ones down here, what you end up doing is You end up parsing the whole tree, even if you're parsing this one, just so that you can get all the relationships. We do all the including and stuff. Um, hmm. Maybe we could have the parser say whether or not function signatures changed. Well, then we have to reparse all over again. I don't exactly know what Bill's. Well, what we can do is, yeah, just like let's add, for now, let's not try to solve how our build system can build things most efficiently. Instead, let's just try to make the parser flexible under the hood so that it can generate things selectively. We'll figure out how to do the selections on what to generate later. Okay, so I think that's how we're going to approach it. So that means we're going to take in some options, and those options will probably be something like generate. Stop converting that. How do we spelling grammar substitutions smart dashes? Turn that off. Okay. Stop or generate parent. Generate child. Generate base, because I think what includes empty.cpp. Empty.h. Yeah, they both empty parent and empty child include, or like empty child.h includes empty.h. So that's the stuff that they both include. Generate base, and then generate message headers. Message. What do you mean? Definitions. That's a lot of the word generate. Maybe just gen parent, gen child, gen base, gen message, definitions. So I guess let's start adding those options. Add gen parent, gen child, gen base, gen message definitions, and make this a thing we can pass to the compiler module. Okay, create a new project branch. So git checkout B, we're going to call this generator. And we've checked out we've got a new branch here, so we've created a new project branch. Done that. We're going to add these things. What's the next step after that? Then we're going to study codegen.py to figure out how we can generate the bare minimum amount of C++ H stuff for each of these things. That's probably just like the comment, because if you notice that at the top of each header and like C++ file, there's this like warning, code generated by such and such, do not edit. It'd be like very great if we could just like, for each of these things, we output just that comment. We'll start there. So let's do that. what are we going to do? We're going to start by saying we're going to add some new options. So I'm inside, oh, whoops, I'm inside ipdl.py. We don't want to mess with that. We want to mess with parser.rs. No, not parser. Main.rs is what we want to deal with here. And we're going to add our options here. This is where we generate the parser. We're going to say opts, opt, p, gen, what was it? Gen parent. Generate parent classes. Parent class and header. And then I want a default value of true. Like if we don't pass anything, we're just going to have it output everything, I think. So rust opt or get opts. Get opts. How do we use this thing? We need like default. How do you set default value? Options. Opt. Oh, that's interesting. It doesn't have defaults. Rust get opts defaults. Default. Doc opt. Using unwrap or value of unwrap or like config equals unwrap or got it. Okay. Wrap or is there a defaults to conf matches valid config? Okay. So I'm gonna say defaults to true. We're gonna do the same thing with gen child. We're gonna do the same thing with gen base. We're gonna put that at the top actually because that makes more sense structurally. Generate the base class, base protocol class. And then what was it? Message definitions. Oh, this should be B, P, C, M. Gen message defins. Generate message definition. Message definition. Is it a class? What does it create inside the, what was it? IPC message type name.cpp. It's a struct and a switch. String from IPC message type. Generate message headers and switch dispatcher. And then like what? Who calls string from IPC message type? IPC glue. Protocol utils. Generate message headers. It's not a dispatcher. And utilities. Message headers and utilities defaults to true. I'm gonna say let gen base equal, what was it? Unwrap or? Or value of matches value of options, get ops value of, no, example opt present output opt stir. What's opt stir? Opt stir. Options new matches equals opts parse. Oops. Parse. Opt define returns true if the option was defined. Returns true if the option was matched. True if the option was defined. Gen base. Wait, hold on a second. I kind of screwed up here. Generate base protocol class and header defaults to true. I don't think we should default to true because like would we say like gen base false, gen parent, gen child, so I think we should just like not default to true. Gen base. So we're gonna go matches dot. If an option was defined, if an option was matched, what's the difference? Defined versus matched. Default. Opt defined, opt present. I don't know what the difference is. Opt present, but that's what's used in the example. So opt present b gen parent equal matches opt present p. Let gen child equal matches to opt present c. Let gen message defins equal matches opt present m. Compiler compile. And I'm going to say gen base, gen parent, gen child, gen message definitions. I mean, we could make that a struct of things that we pass, but let's not clean it up just yet. And then in compile, compiler.compile, we're going to take gen base, bool, gen parent, bool, gen child, bool, gen message definitions, bool. And then I'm going to say if gen base print line generating base class and header if gen parent, I'm just doing this to test to make sure it's working, generating parent protocol class and header if gen child do this but child protocol if gen message definitions, what did I call it, print message headers and utilities, message headers and utilities. I'm going to reverse it, send header, and then generate message utilities and header. Also note there's no period after any of the other ones, so I'm going to get rid of these. Alright, let's see if that will build. Cargo build. Nope, doesn't like it. Unused. Oh, I don't need parentheses. That's interesting. I didn't realize that, but under the compiler, I don't need these parentheses. So that's one thing. There's a warning there, and I'm also not using. I'm not using the opt correctly, apparently. So let's take a look at what's going on there. Opt. This function takes 4 parameters, but 3 parameters were supplied. So we're supposed to pass 1, 2, 3, and then something else. 1, 2, 3, 4. This one has, oh, flag. I should use opt flag, not opt. Opt flag. Let's try that. Building. Doesn't like it. Matches value used here after move. So I freed the matches. That's interesting. And matches.free. Matches.free. What does that do? Free string fragments. matches dot free, and then it tells me use of partially moved value. It was partially moved. Value used here after move. Move occurs because matches free has type such and such, which does not implement the copy trait. Matches. Should I do like clone free? Matches.clone. So do a copy. Here's an interesting thing. Like, what if I were to f matches.free? Oh, because each f is inside matches. I see. So I've pushed. Okay. So now, now that I've built that, if I were to do target debug IPL parser, and then let's do CDU workspace, and I'll go target debug IPL parser, and then I'll pass it empty.ipdl, and then I'll say p, generating parent, p c, just c, just g, doesn't recognize g, h, how about m, yes, generate message utilities, b, base protocol. Okay, good, so that's working. I don't know if I'm super happy with this function signature getting so bumped up with bools, but maybe it's okay. So maybe the compiler should come out with like children, and then parents, and then base. Generate classes and headers. Yeah, because we can pass multiple classes and headers. So header is headers. I think there's only one header. So then gen message, I'm going to call it definition, I'm going to call it utils main utils. Okay. So now let us maybe generate some stuff. We've reached the point. We've got like 20 minutes to go. I want to maybe try to generate just the bare minimum stuff. I don't know if we're going to write it to a file, or maybe we'll just like print it to the console. But we're going to just try and generate some bare minimum stuff. But first, I'm going to check that off the list. We've done that. Now we're going to study CodeGen to figure out how to generate the bare minimum, then generate the bare minimum, and either put it on screen, either print line it or send it to disk. Okay, so codegen.py is what we were told to check out. And then someone gave a recommendation on what exactly to look for. Nathan said, start grepping for CG thing and find interesting things. So CG thing. So class CG thing is a base abstract class for things that spit out code. And it has like produce the deps for a PP file, produce code for a CPP file, produce code for a header file. CG thing. So for example, what implements a CG thing? A DOM.js class. The declaration is nothing, but the define, we like do all this processing, and then we add all these flags and stuff, and then we have this like structure that we fill in. Okay, we have this like structure and we fill it in using formatted strings. I gotcha. I gotcha. Now I wonder if there's something like, so I'm looking inside lower. This is the IPDL parser written in Python. Um, child.cpp. Child header. Generate protocol parent code. And generate protocol child code. Parent code and generate protocol child code. What's the difference? Generate protocol parent code is just going to do generate protocol actor code. It doesn't do anything special. It just gives itself, I think, a different name. Generate actor code. Side. Oh, it says what side it's on. And then self.side. And when is side used? Self.side is parent. Actor, title, side. Side.title. Side equals parent side.title. What does that mean? Def title. Title. What's a title? What are we talking about here? It's supposed to be a string. What's string.title in Python? Task.title. Oh, what? What Python string title? What is... Returns a copy string which the first characters of the word are all capitalized. Ah, title cased. I understand. Okay. So maybe it should be something like define, perhaps we create a trait thing like CG thing, except instead of just define, declare and define, which CodeGen's class CG thing has. Declare, define. Maybe declare and define will take aside. Or we'll have declare child and declare parent and declare define child and define parent. Would that make sense? Because then the compiler will be like, okay, come up with if we're pseudocode time. I'm just trying to think this through here. Pseudocode time. If gen child thing dot declare child header string equals thing to declare child CPP string equals thing dot define child if gen parent, and then like write to disk or write to hash table of things to go to disk, I guess. Gen parent header string equals thing dot declare parent CPP string equals, sorry, you probably can't see that, thing dot define parent, and then write that to the hash table of things to go to disk. And then you could do, and then we'll need one for base as well. If gen base header stir equals thing dot declare base CP stir equals thing dot define base, and then write to disk. So we could do it that way. It's kind of weird because I guess, no, that's not so weird. Because the base, the thing in this case will be like the root of a tree, and it will say, this is how I need to know about base things, and it will like get what it needs from the tree, from the translation unit, do the definition. And then like if gen message utils header stir equal, how's that gonna work? Because like we're gonna need to go through all of the message types of the things we've been passed, like accumulate message types from all translation units. Like this we can do for each translation unit. All of that occurs. Indent. Whoops. How do you? I need to like indent once. Edit. Oh man, how do you... Just need to indent once in Evernote. Come on, there's got... Oh, increase indent level. Yes. What? So broken. I'm gonna try this down here. Increase indent level. In a list. Oh, just text. Increase indent level. And now... I probably didn't need to take it out. I probably just needed to like do it properly. Yeah, but like that is what I'm talking about. For each translation unit, do that. And then this is outside of all the translation units. We're going to have to maybe like if gen message utils add message data to accumulator and then blast out message data to hash table. Okay. I think that's how it's going to work. Because we only want to like iterate the translation units once. I don't have to do multiple waves. This stream might go a little bit long. It's 2:22 now. I am... Oh man, I had like 2.4% of my frames have dropped. Sorry about that. But we are at 2:22. I don't know if there's any chat going on. Let me just check it out real quick. Not really. I'm just going to keep going. It's possible. Like I just want to get something out, just like the bare minimum, just the headers, and that means that not even the headers. I'm just going to get like a boilerplate comment, and what that means is I think I'm going to define like how am I going to structure this code generation .py uses CG thing. And it's using classes. Rust doesn't have classes, it has traits. I think we want to define something similar. So let's look at how we can declare a trait. Rust traits. So trait, code gen CG thing. Wait, now how does it work? Well, how does CodeGen take a CG thing? Like CG string table, for example. Append prototype list at global gen roots. Roots for global CodeGen. Prototype list. CG event root. Class constructor. Abstract static method. Maybe I need to see like how this thing actually works. Like CodeGen.py is going to, it has all these classes, and now what first makes use of any of these classes? Like where's the entry point to this like tree of things? CodeGen.py. Who calls CodeGen.py? Main CodeGen.py. Is there CodeGen.py? Moz WebIDL CodeGen. There's an init.py. Build result WebIDL manager state. Main. There's no main in there. So how does it work? It's probably not executed directly. It's imported by someone. Create build system manager. WebIDL CodeGen manager state. build result, Moz web IDL code gen, mock commands, web IDL provider, generate example files, and we import that, and then we say generate example files, web IDL test. That will run the parser tests. How do you get it to like actually make use of the parser? Manifest. Mocks web IDL. Action. Main. Generate build files. This is it. I think this is it. WebIDL.py. So def generate build files is here. So how does it work? We have this thing that, how's it called again? We construct it, build system WebIDL from environment manager. And so I guess that gets constructed smartly somehow. It populates all of these things. And then we call parse WebIDL. So we create a parser. We get the parser results. We have some kind of configuration. So then we're done parsing the WebIDL. Result equals build result. If we parse, so write global derived. We parse, we always update globals. They're cheap and it's easier that way. Right, global derived. If any of the extra dependencies change, regenerate the world. Global dependencies changed. Generate bindings for file name in changed inputs. Changed inputs. Compute changed inputs. Compute the set of input files that need to be regenerated. Look for missing output files. Say, for example, we should examine SHA-1's available files from freeze run to detect modifications. So that's a lot of extra work. Most build systems don't do that anyway. Now we move on to the input files. If an old equals self changed inputs equals a set input paths. Now we move on to the input files. If an old file has disappeared or a new file has arrived, mark it. For the files in common between runs, compare content. If the file has changed, mark it. We don't need to perform time comparisons because content is a stronger validator. If old hashes is not equal to input hashes. So that's interesting. They've hashed the files, changed inputs, add file name. We've now populated the base set of inputs that have changed. Inherit dependencies from previous run, full set of dependencies associated with each record. We do the dependencies only use paths that are known in our current state. So for each of the web IDLs, if there are any dependencies in changed inputs, then we need to add oh man, it's kind of hard. So we go through all the web IDLs, and if any inputs for V is in changed inputs, so if we've changed any of them before, in the I guess inputs is like a dependency. If any of the dependencies of V inputs has changed, then we need to add the dependent. Okay, we need to add the dependent to the list of changed inputs. So I'm gonna, this is actually really interesting. Permalink. Here's how. Come up with how we're going to do to generate the bare minimum of things. Bare minimum of things. Code gen WebIDL parser does that here. Of dependencies. That is what, like, generates everything at once. So maybe I got it wrong rereading this and looking at how CodeGen does it. Maybe he's not saying be able to selectively generate just the children or selectively generate just the parent. Because I think when the parent changes, the child has to change. If something's changed on one side, then something has to change on the other side. So I don't think it's actually useful to be able to say just generate the parent things or just generate the child things. That's good to know. So we may have actually wasted a little bit of time there doing that, but that's good to know. And then where are these hashes coming from? Old hashes. We take the input files. We have this set of old hashes, keys, old file names, and new file names is the input paths. And then we check old hashes against input hashes. Where does input hashes come from? SHA-1 self input hashes. Hashes parse WebIDL will come up with open path and sorted input paths. When we're parsing, we're going to read the file, then we're going to hash it, and parse it. Input hashes. Okay. When it's parsing, a set of input hashes are generated. So I wonder if that's something we could do. Yeah, over here in the parser. Result a translation unit or a string. Maybe we can say the translation unit has a hash. Translation unit. IPDL parser. Translation unit. Built in using vector pub struct. Pub. Maybe we should say like, yeah, pub hash. Maybe that's where we should start. You know what? I'm gonna blow away a lot of what we did. Um, I no longer think it's useful to be able to selectively generate the parent, child, or base. Because I think if we generate, unless I'm mistaken, unless we're like having something external figure it out is not correct. Internally, we have to figure out whether or not we're supposed to be generating these things. Although generate message utils might be useful. Except that we know that if if it's we have to do all of it. No, none of this is useful. We're getting rid of it. We're getting rid of it. I'm sorry, folks. I'm sorry if that was I made a mistake. I made a mistake. Boo. Boo. It's okay. Making mistakes is okay. But not useful. I thought it was useful, but I was wrong. Compiler.rs. Don't need to do any of this stuff. I was wrong. The compiler needs to understand when it should generate those things. Because it's gonna like examine the whole tree anyways. Okay. So then what I want to do is maybe what we should do is I'm just repeating myself. Add hash to translation unit and calculate it for each input file. Now, where's uncommenter work? How's uncommenter? Uncomment. Uncomment, parse file. We uncomment it. Vector of BIOS lists all new lines in the input used to resolve. Says push offset. Okay. Let's figure out how to calculate the hash. SHA-1 Rust. There's a crate for it. Oh man, we're gonna have to bring in a whole full-blown crate. Rust built-in hashing. Standard hash. Standard generic hashing support. Hash. Structure with simple build hasher. Are there? Oh man, that's generic hashing support. I need like. A couple types for hashing. I need to combine different hashes. Let's see how you hash things. I need to like create a SHA-1. How do I use hash? Which means sorry, I didn't mean to use like make fun voice. I didn't mean to do that. Sorry. When people are asking questions, that's not cool. I want to like. It doesn't have to be SHA-1. It could be like Rust trapdoor function. Trapdoor. One-way function, compute way. Maybe not backdoor, but or trapdoor, but like SHA-1 or MD5. Anything like that. Rust crypto. Rust standard crypto. Crates. I just want to do SHA-1 hashing. Maybe that's it. Minimal. It's a minimal implementation. We don't need the full-blown crypto library. Just SHA-1. Crates.io owners. So it needs rand and OpenSSL on dev dependencies. No other dependencies. And then here's the repository. Source. Very small. That's good, I think. Spray and pray. Okay. Random number generator. That's interesting. Oh, I know this fellow. I think. Yeah, I recognize that fellow. Creator Flask. How do we use it? Let's look at the test actually. SHA-1 new. OpenSSL crypto hasher new. I want to use OpenSSL. What's the implement SHA-1? SHA-1 new mute m, so when's m used? M.reset m update bytes m.digest. So we write to it and then we do a digest. There's no documentation. Oh wait, here it is. Here's the documentation. SHA-1 new update. We give it some stuff and then we digest it to a string. Okay. So let's bring it in. Ring-a-ding-a-dingy. Let's do this thingy. So we say cargo dependencies SHA. What was it? Rust SHA-1 or just SHA-1 equals 0.2.0. And then I'm gonna need to bring it in here. I think pubmod ast. Do I need to do it elsewhere? Maybe. Extern create SHA-1. I think I have to do that. And then main extern create SHA-1. If I don't do that, what happens? Does it build? Cargo build. Downloading SHA-1. Compiling SHA-1. That was a fast compilation. If I do cargo test. Okay, maybe I don't need to add it to this list in here. I might need to do later whenever I start actually using it. But I don't actually need to bring it in there. I think I have to bring it in the parser. Extern create SHA-1. And and then translation unit. Parse translation unit. Can I just like add like after the fact, like post facto parse translation unit, parse translation unit, text parser state, and then that returns a translation unit probably. Pub function returns a result, which is a translation unit. And then so what I want to do is instead of namespace thing, preamble, namespace thing. Is it possible maybe to even do this inside Lollipop? Using Lollipop tutorial. Type inference, full featured expressions, building up an AST, macros, error recovery. What I'm looking for is more advanced. Whole file string. Translation unit. It's the preamble. PS. Namespace thing. PS. What is PS? Start. String. NS. Preamble. Preamble statement. Define a grammar. Need the input. Parse input. Lollipop hash. Is there an example? Or a Lollipop SHA-1. Okay, well I think we might have to do it post facto. I mean, like, we don't do it within Lollipop, but let's see if we can just like have this hash be a property on translation unit, and then after we've parsed we can like attach it. Or maybe even better, what do we have here? We're returning a hash map of path buffers to translation units. Maybe we should return meta information. Instead of translation unit, we should be like return meta information. The translation unit along with the SHA. That might be better. Parsed struct. So I'm thinking we need a new struct here. Pub struct parsed parsed a parsed file. Parsed IPDL. Is going to have pub TU translation unit and pub SHA hash, which will be a string. So instead of returning a result of instead of doing this, we're returning hash map pathbuf to translation unit. We're going to say parsed IPDL. Parse file, let tu equal match parse file. Parse file includers cur file in work list. Cur file. Then it uncomments it, opens it up. This is when we should generate the thing. So we're going to return a parsed IPDL. Maybe we'll call it parsed file. Or, yeah, a parsed file. Parsed file result. Parsed file. So instead of a translation unit, we're going to get a parsed file. OK. Parsed file. Parsed file. Otherwise, error message. For each include parsed file tu.includes. Resolve include path. Parsed insert. Cur file clone. Where's parsed use? Return parsed. Sum parsed. Insert Instead of tu, we're going to return parsed file. And so up here, we're going to create a new struct. Let tu equal that. Return, how do we make a circle, for example, in the struct? We have a struct SQL. All right, return parsed file tu and hash nothing. Well, like that. Parsed file cargo build. Doesn't like it. Struct field shorthands are unstable. Okay, so it doesn't like that. It wants tu. Expected struct, found result, return, a result, parsed file of string, let tu equals let tu equal that. A result, hang on, I need to not panic, but like if it's an error, tu if result equal that, if result dot is okay, rust result. I'm gonna have to go in a couple minutes, folks, because I have a meeting in 2 minutes. But I really want to get this done. Result is okay. Return result. Otherwise, return not result, return can I do that? Return the result because it is an error, which is a string. Otherwise, we're going to return a parsed file result dot unwrap. Can I do that? Missing hash. Okay, translate. I accidentally left. Oh, I want to get this done. I want to get rid of that. Just want this to happen. Result expected struct parse file found struct parse return result at line 144. Expected struct. Okay, yeah, it doesn't like it. Return result is an error. How do you like propagate that error? Return error. Result. Like that. Found enum result as error. How do you get the error out? Result. Rust. Wrapping errors. Error handling. Parsing result. Working with multiple error types. Composing. Returns the try macro. Extract early return. So try. Let tu equals try. Result. So like that. Ooh, it does. And then instead of returning nothing, we're gonna nothing dot. What have I done that before? I've done something similar. To owned. To owned. Whenever you use a to owned. Expected enum standard result found. What? Parser rs return sum. Return OK. Yes, that works. Okay, I have to go. I have a meeting. But I'm going to keep working on this after my meeting, and maybe you'll see a pull request soon. This has been a little bit of a scattered episode. I apologize. I was kind of making things up. Someone asked in live hacking, how did I go from beginner to fixing bugs in Rust? Great question. I read the Rust by Example book, and I'm still learning. Best way is to just dive in, I think. Yeah, it's like I'm still learning. I'm still a beginner. I'm still a beginner, I'd say. Okay, I gotta go to my meeting. Thank you so much for watching The Joy of Coding episode 87. I hope that was sort of useful. Please rate this episode. I know I went a little bit long. Please rate this episode. There's a link inside the agenda right here. I'm going to drop this into the live hacking channel as well as the Twitch chat. I'd love it if you could fill that out and let me know what you thought and what I can do to make this stream better. Go. And so I'm heading out. Thank you so much for watching episode 87 of The Joy of Coding. I hope that was enjoyable. I will see you next week. Take care. Bye-bye.
The joy of coding.
See ya.